Come on, y'all. Let's be honest with ourselves. We are absolutely obsessed with sunsets. Do not act like you do not have thousands of sunset photos stashed away in your phone for no reason at all. But boy, are they gorgeous. But to truly appreciate the beauty, you need to understand it. So, as lifelong learners, let's take this moment to really dig deep and understand what makes these special moments happen in our sky.
With this possibility just around the corner, let's find out what Mars sunsets are going to look like too.
It all begins with the Milky Way's favorite star, the sun. The sun emits white light. White light is a combination of all the colors of the rainbow, everything from the Roy to the G to the BIF. This is best described using the electromagnetic spectrum. In the case of visible light, or all the colors of the rainbow, we see that red has the longest wavelength, while blue has the shortest. This comes in handy later, so just remember that. These colors approach Earth's atmosphere and are scattered in all directions. This is because Earth's atmosphere is composed of nitrogen, oxygen, inactive gases, and even smog that clutter up the space the waves are oscillating through. The blue light waves scatter much more than other colors, because blue light waves are smaller and travel shorter. This particular scattering is considered Rayleigh scattering. This is the reason why our sky is blue most of the day. Pause. Misconception time. You heard me right. Scattering, or Rayleigh scattering, is the reason why our sky is blue. So, no, unfortunately, it's not the big blue ocean that makes our sky blue. But now you know. And now, you'll be really cool at parties. Remember, sunsets only happen when the sun sets, or when the sun is closer to our horizon. Now the sunlight must reach through even more of Earth's dense atmosphere, rather than when the sun is straight above us. Even more of the blue light is scattered now. Think of it as filtering out. Those poor small wavelengths can't possibly make it through the hustle and bustle of all those air molecules, so we don't see the blue light scatter in our line of sight. And the winners of this race are the longer wavelengths, red, orange, yellow, creating those picture-perfect images that we see all over the internet. But then there's the ultimate question. With all this talk about us going to Mars soon, are we still going to have those same beautiful sunsets all the way on the red planet? Well, just like how scattering is dependent on the position of the sun and the composition of the atmosphere, we have to dive deeper into what Mars is about. Mars's atmosphere is mostly made of carbon dioxide and lots of dust particles. All of these tiny particles scatter light differently than the particles that make up our atmosphere on Earth. Which means that after Rayleigh scattering occurs, Mars gets a nice hue of red during the day, and a beautiful cooling blue during the evening. Like this. So don't be sad the next time you have to make your trip to Mars, because those sunsets will be just as beautiful. Just definitely not red.